All right, for Friday's notes, we are continuing with system of equations, but this time, this title of the notes is going to be multivariable system of equations. So pretty much, students will be able to solve two or more equations involving two or more variables. So on Wednesday notes, we were just focusing on two equations with two variables. This time we're going to do more because more is fun. So, system of linear equations. We will now begin to work with the system of linear equations that have more than two variables. This is very common when working for computer programming. So if that's something you are interested in doing, this is something you might need and apply in your future life. So first method is called the row of echelon form, and pretty much it means it has like a stair step. So if you look at the example down here, you can see that it is growing as a stair step. So it's like you're going upwards. This is pretty easy. It's kind of like its own substitution way. So I gave you the steps. These are a little bit simpler to follow. So step 1, substitute z into equation 2. So we can label them. This is equation 1, 2, and 3. So then I'll have y plus 3 times whatever your z value is, which is 2, we will plug in. And then we solve. And we get y plus 6 equals 5. Subtract 6, subtract 6. Y is equal to negative 1. And then it says solve for y. We did that. We did step 1, step 2. And then it says substitute your values. It says values because now you have two. You have z and y. So I'm going to substitute those values to find x. And I'm going to plug them into the first one. So x minus 2 parentheses plus 3 parentheses equal to 9. So in there I'm plugging in. Z was 2. Sorry, that's y. Y is negative 1. Z is 2. And then we solve. So then we get that x plus 2 plus 6 equals 9. X plus 8 is equal to 9. Subtract 8, subtract 8. X is equal to 1. And this is 3 equations, meaning that it's a 3-dimensional graph. So then we have technically 3 lines, and they intersect at the points 1, negative 1, 2. It's kind of weird how it like goes. It's like 3 dimensions like this, and they like intersect somewhere right there. But we always have to check our solution. So that still is the same and is applied. I am going to check my coordinate points. So I plug in 1 minus 2 times negative 1 plus 3 times 2. Will that equal 9? 1 plus 2 plus 6. Will that equal 9? 3 plus 6. 9 does equal 9. So this is a solution. All right. So you're going to try, and this is what I'm going to check when you come back for your notes. And we will move on to method 2. So method 2 is its own elimination method. So it's a sequence of operations performed to change the system of equations to fit a row of echelon method. And this will make a little bit more sense as once you see the math moving. Step 1, let's begin by labeling it. There's equation 1, equation 2, equation 3. So then step 1 is telling us, do the elimination method on equation 1 and 2. So these two equations, I am going to do the elimination method. And I can already see that the variables that are going to be eliminated are going to be my y's, because they are the same number but opposite signs. So then those cancel. I combine 2x, I combine 2z equals 4t. And then I will do the elimination method with equation 1 and 3. You can do 2 and 3, but 1 and 3 will be easier because 1 has that negative 2y, which would eliminate with the positive 2y from equation 3. So then writing this down here, and then this is equation 3. So then these again eliminates, and I have 4x minus 2z is equal to 4. Now you can do the new elimination method with the new equations you have. So I'm going to bring this one here, this one down here, and we're going to do the elimination for these two. And this example just worked out very nicely, because then the z's cancel. If nothing were to cancel, you would just multiply your equation. You get 18 divided by 6, x is equal to 3. And once you have one value, the rest is pretty easy, because then you just start to plug back everything to where you would need to find something else. So I can plug this 3 back into this one here. 4 times 3 minus 2z, and then I would get the variable z. So then I went back here to plug in. And then I get minus 12 minus 12. Negative 2z is equal to negative 8 divided by negative 2. Z is equal to 4. And then you can plug x and z back into one of the original ones. So then we're going to plug that into equation 1. 3 minus 2y plus 3 times 4 is equal to 1. So then 3 minus 2y plus 12 equal to 1. 2y plus 15 is equal to 1. Minus 15 minus 15. Negative 2y is equal to negative 14. Y is equal to 7. And I have now my coordinate point of 3, 7, 4. But what do you always have to do? We need to check. And I'm actually going to check back up here, because I ran out of space. So then I plug in 3 minus 2 times 7 plus 3 times 4. Does that equal 1? This gives me 3 times negative 14 plus 12 is equal to 1. That gives me negative 11 plus 12. 1 does equal 1. So yes, it is a solution. So multiple steps. We went to the right first. This was our step 1. And then we went over here. This was our step 2. Then we went over here. This was my step 3. And then we went to the plugin, and that was my step 4. And then I went to my blue. That was my step 5. And then my check was my step 6. Just so it's a little easier to follow along. Alright, and then I will be checking your U-try. When you come back next week. Alright, I'll see you on Monday. I hope you guys had a fun trip. Make sure all your work is complete. I will be collecting it on Monday.